Hello, Math 154 students, and welcome back to part number 2 of Unit 3, homework number 1. In this section, we're going to be talking all about compound interest and how that is different from simple interest, which is what you did in the first half. So let's take a look here and first define what does compound interest mean. So the big difference, again, between simple and compound is this. Interest is reinvested. So the interest is reinvested. So what does that mean? That means that interest in the next period, interest in the next period is earned on the principal. Remember, principal was the initial amount from simple interest, plus previously accumulated interest. We're going to take a look at what that means here shortly. But again, the big idea is interest is reinvested. So you've also probably heard of APR. APR stands for your annual percentage rate. Probably heard of that with your credit cards. And APR means the total interest that will be paid in the year. Okay, so for example, down here at the bottom, if interest is paid in smaller time increments, the APR will be divided up. So for example, if you have a credit card with a 24% APR paid monthly, that would be divided up into 12 2% payments over the course of an entire year. Okay, so that's what that means there. Okay, guys, so let's go ahead and look at what this means here in terms of reinvestment. That's what we're going to do here right below the APR box on your notes. So how does compound interest work and how is compound interest different from simple interest? Let's do that by exploring the following scenarios. So you borrowed $5,000 for a year. Interest is 4% and compounded semi-annually. How much do you owe? Semi-annually, by the way, means this means twice per year. So if you think about your favorite store that has a semi-annual sale, and why is that a big deal? Well, it's a big deal because it only happens twice a year. All right, so what we have is we're going to take the first 6 months. Okay, so remember our formula for interest, simple interest, A equals P sub 0 times 1 plus R times T. So in the first 6 months, we take that $5,000 that we invested times 1 plus. Now my interest rate is 0.004, but I got to divide it by 2 because I've got 2 time periods here. This is not an annual. I'm doing this twice. Okay, so times 1 for the time. And this one here is there is 1 6-month time period in the simple interest formula. Okay, so I have 1 6-month time period in the simple interest formula. So when we do this, let's hop over to our calculator. Now, by the way, guys, 0.04, oops, that's not your calculator, is it? Here we go. The 0.004, that is going to be divided by 2 because just like I made that little note about compound interest, we have 4% over the course of a year, so we're paying a 2% interest payment for the first 6 months and a 2% interest payment for the second 6 months. So we have 5,000 times 1 plus 0.004 over 2. I can put it in like that if you want, or you can put in whoops, hold on, I got too many zeros in there. Whoops, 0.04, there we go. 0.04, and we come out with $5,100. So let's go back to our notes here. All right, so we've got $5,100. So now, if this were a simple interest agreement, at the end of 6 months, this is how much I would be paying back here. If it were 2% or whatever it was. But now remember, now I have to do my second 6 months. So let's do the second 6 months. Now again, we said the interest is reinvested. So now my P sub 0 is not 5,000. My P sub 0 is going to be 5,100. Okay, so this is where the interest was reinvested and added to the total. Okay, so we have 5,100 times 1 plus 0.04 over 2 times, 1 here, whatever you want to, just like we had above. All right, so now I'm going to go ahead and compute this piece. All right, let's see what we got. So the nice thing, here's a nice little trick about Desmos, guys. I don't have to retype that whole thing. Backspace there, insert the 5,100, voila. So we have 55,002 here. 52, yeah, hold on, guys. All right, so let's record this answer in our notes. So we came out with 5,202. All right. Now I want to just emphasize again, how is this different than simple interest? If this were simple interest, let me just go back to the calculator and show you. If it were simple interest, it would have been 5,000 times 1 plus 0.04 times 1. You would have come out with $5,200. Notice that with compound interest, you actually made $2 more. Oh gosh, it would help if I had the screen share on, wouldn't it? Oh my God. Here's screen share on. There we go. So notice with compound interest, you made $2 more than you would have made with just a straight simple interest agreement. Okay, so that's the power of compounding. Now the number here is really small, but it's much bigger with larger numbers. All right, so let's just make a little note here. This is, $2 more than just simple interest. Okay, so just the simple interest would have been, A equals 5,000 times 1 plus 0.04 times 1, which is $5,200. Okay, so questions, issues there? I think we're good now. All right, let's go to a formula for compound interest, because I don't want to have to keep doing, multiple calculations like this if I were doing monthly, I'd have to do 12 of these calculations, one for every month, and I don't want to do that. So we have a little formula for compound interest over time. So compound interest over time is P sub n is equal to P sub 0 times 1 plus R over K to the nk power. So what are these variables defined to be? N is our number of years. Compound interest will always be done with years. P sub n, this is like your A value from simple interest. P sub n is the amount in the account after n years. P sub 0, this is our principal. So this is just like with simple interest, this is our initial amount, our starting amount. The R value here, guys, your R value, this is your annual annual interest rate. So it's always given to you as an annual amount. And of course, we want to have this in decimal form. And then finally, the K value is the number of compounding periods. So in that last example, we just did semi-annual, which was 2 compounding periods. So they're always going to define the number of compounding periods in 1 year. All right, so let's take a look at some common compounding periods here at the top of the next page. So if you have an annual compounding, that just means once. Semi-annually, twice. Quarterly, think about 4 quarters in a dollar. So that's 4 times a year. Monthly, there's 12 months in a year, so 12. And then if you have a daily compound, looks like we have an extra L in there. Let's take that out. That would generally be 365. All right, so just a little note here about this daily compounding. Some books will use 360 or this should say 364.25. We're going to stick with 365 for daily compounding. Okay. Now you will see in your note on one of your homework problems, you're going to see something called the banker's rule. It's going to refer to the banker's rule. The banker's rule says that we have 360 days in a year. So the banker's rule, when you see that in your homework, it's going to say use banker's rule. That means the K value is $360. Okay. All right. Questions before we move on and do a couple example problems? Okay, guys, let's take a look here at example 7. You deposit $2,000 in an account earning 3% interest compounded monthly. How much will you have on the account in 10 years? All right, so just like we did with simple, we're going to do the same scenario with compound. We're going to list out what we know and what we don't know and identify the formula. So P sub 0 is equal to 2,000. That's the initial amount that we deposit the principal. Interest rate is 3% or 0.03 as a decimal. Now it's telling us that it's compounded monthly. That compounded monthly is my K value of 12, and I'm doing it for 10 years. So N is equal to 10. What I'm looking for is the account balance. That's my P sub N, or in this case, it would be P sub 10. So our formula for compound interest, P sub N is equal to P sub 0 times 1 plus R over K to the NK. All right, so we're looking for the P sub N or the P sub 10 here. So we're going to be 2,000 times 1 plus 0.03 divided by 12 raised to the 10 times 12 power. Now, we want to be fluent with our calculator here. We want to be entering everything in one step. Don't enter what's inside the parentheses and then try and round it off. You don't want to do that. Same thing we did with compound interest. So with simple interest. So we've got 2,000 times 1 plus 0.03 over 12. Right arrow to get out of the fraction. Close the parentheses. The raise to button for Desmos is you can do one of two things. You can hit shift number 6, or the A raised to the B button, this button right here in row number 1, the second one in. So raise to, since we're entering a product into the power, it has to be in parentheses, whether using handheld or Desmos, has to be in parentheses. So we've got $2,698 and rounding to 2 decimal points, 71 cents. So let's go ahead and record that here. So we come out with $2,698.71. All right, so again, one step entering is where it's at. Okay, guys, let's take a look here at example 8. You're saving for a new car. How much would you need to deposit in an account now in order to have $6,000 in the account in 5 years? Assume the account earns 7% interest and is compounded monthly. All right, so we want to have $6,000 in the account. All right, so that is our P sub N amount. P sub N 6,000. We know that the interest rate is 7% or 0.07. We know that K is equal to 12 because we're compounding monthly. And we know that our N value here is 5 because we're doing it for 5 years. And we're looking for the initial deposit. That's our P sub 0. So our formula, P sub N is equal to P sub 0 times 1 plus R over K to the NK power. All right, so subbing in what we know, we've got 6,000 is equal to P sub 0 times 1 plus 0.07 over 12 raised to the K N times K. So that's 5 times 12. So I want to get the P sub 0 by itself, so I'm going to divide out the entire right-hand side. That'll isolate the P sub 0. Just like, it's just, guys, this is just like dividing out a number in front of a variable. It's the same thing from your Algebra 1 days. Cancel out. So P sub 0 is equal to 6,000 divided by 1 plus 0.07 over 12 raised to the 5 times 12. And again, we want this in the calculator in one step. So we're going to go ahead and go to our Desmos calculator here, model for you. I need fraction. And we have 6,000 divided by, parentheses here, 1 plus 0.07 over 12, right arrow to get out from under the fraction, close the parentheses, raise it to, you need a parenthesis here because we're multiplying. It's 5 times 12. Right. Close it up. And we've got $4,232.43. Okay. So let's go ahead and record this. Notes. So we've got $4,232.43. All right, so there's example 8. Let's get ready here to hop over and do example 9. You guys, let's take a look at example 9 here. A student has the choice of 2 different banks at which to invest $2,000 that she earned at her part-time job. Both banks offer an annual percentage rate of 6%. However, the first bank's interest is compounded quarterly, and the second bank's interest is compounded monthly. If she doesn't deposit or withdraw any money for 3 years, compare how much she would have at the end of 2 years using each bank. All right, so what do we know? Well, we know the following. The P sub 0, the initial amount of deposit is $2,000. The interest rate is 6%, so that's 0.06. And then the number of years we're going to deposit for is 3 years. We're looking for the amount in the bank. That's our P sub N. Using the compound interest formula, P sub N equals P sub 0 times 1 plus R over K to the NK power. Now let's take a look at Bank A. I'll just call it Bank A. Bank A says that the K value here is 4. So we'll have P sub N is equal to 2,000 times 1 plus 0.06 over 4 raised to the 3 times 4. All right, we'll see what that is here. How much money we've got with compounding quarterly at Bank A. So we've got, let's see, 2,000 plus 0.06 over 4 raised to the 3 times 4 power, or the 12th power. So it looks like we've got 23.91 and 24 cents. So this is 23.91.24. Now we need Bank B. Okay, so Bank B says that the K value is equal to 12. So now we've got P sub N is equal to 2,000 times 1 plus 0.06 over 4 over 12. K value 12. Let's fix that. K value is 12 raised to the 3 years times number of compounds is 12. Okay, so now let's see how much we've got in the bank. And I'm not going to type the whole thing because I only need to change 2 numbers. So I'm just going to say copy, paste, and I'm going to change the 4 here to a 12. All right, so we made a little bit more money, $2,393.36. So if you really want to know, let's see how much money we made. 2,393.36 minus 239, whoops, 2,391.24. We made $2.12 more. It's a little, but not a lot. But every little bit helps, doesn't it? All right, so we've got $2,393.36. So conclusion here. Compound monthly is better. Even if only a little. Okay, so we can say, we earned $2.12 more here with Bank B. So just so you know here, if you increased the principal rate or time, the difference between the two would be much more dramatic. So the difference between the two would be more dramatic. Okay, so there we go. All right, so there's example 9, guys. Let's go ahead and take a look here at example 10. All right, so new parents want to open an account to save money for their newborn child's college tuition about 18 years from now. The parents know that the child could lower this cost by attending a community college, and they also expect the child to contribute some through a part-time job, student loans, etc. Therefore, the goal is to save $200,000. So if the account earns 7% interest compounded quarterly, how much would they need to deposit now to reach the goal in 18 years? So what do we know? We know that the P sub n, or the amount we want in the account, is going to be $200,000 at an interest rate of 7%, and it's compounded quarterly for a time of 18 years. We're looking for the amount we need now. That's the initial deposit, which is the P sub 0. And since it's given us a compounding time, therefore we know that we're using the compound interest formula. Okay, so subbing in to our formula here, we've got, let's see here, 200,000 is equal to P sub 0 times 1 plus 0.07 over 4 raised to the 18 times 4. And again, we're just going to divide out what we have over here on the right-hand side. Don't get a decimal over on the right and then divide by a decimal, guys. That is not going to help you. That is going to frustrate you because you will have round off error. So what we have is this. P sub 0 is equal to 200,000 divided by 1 plus 0.07 over 4 raised to the 18 times 4. I want to type that into my calculator right now and get an answer. Okay, so again, no rounding until the very end. So let's go ahead and type this in. We need a fraction here. Okay, so we've got 200,000 divided by 1 plus 0.07 divided by 4, right arrow, close, raised to, parentheses. Don't forget those, 18 times 4. So it looks like we have $57,352.44. Okay. So $57,352.44. All right, so that's a fairly hefty deposit here. So, let's just say here a family that can, oops, so that I can put, say, about $57,000 into savings now. Because $57,000 is quite a lot of money. they probably isn't too worried. Say isn't too worried about having enough money down the road. All right, so this is not really practical. Missing a C in here. Practice. Oh gosh. Okay, the pen is work. My mind is going faster than the pen. Practical. There we go. It would be better, honestly. It would be better to save a little at a time than to have a huge lump sum. You invest now. All right. So you invest now and never really touch. Okay. So we'll say, more ways to save coming. More ways to save are later in the unit. All right. So you can, the point here, guys, $57,000, that's a lot of money to have to put out right now. So we'll look at some ways you can save money by putting in smaller amounts over a time period later on in the unit. Okay, guys, so let's take a look at our last example here for compound interest, and this is in example 11. Sarah made an investment of $6,800 at a rate of 12.6% for 4 years compounded annually. Determine the end amount of Sarah's investment. Okay, so again, what do we know? We know that she invested $6,000 at an interest rate of 12.6%. So that's going to be 0.126 as a decimal. She's going to invest for 4 years, compounded annually, so that's once. We're looking for the amount of money. All right, so we're using the formula P sub n is equal to P sub 0 times 1 plus R over K to the NK, the compound interest formula, because they gave us a number of compounds. All right, so what do we have? So P sub n, or P sub 4 here, is equal to 60, oh wait, this should be 6,800, right? Was it 6,000? Yeah, 6,800. Let's make it 68, so right. 6,800 times 1 plus 0.126 over 1 raised to the 4 times 1 power. All right, let's see how much money Sarah will have in her account. So we have 6,800 times 1 plus 104 over 1 raised to 4 times 1 power. And you really could just put in 4, but it looks like, oops, hold on. I got the wrong interest rate in there. That should be a 0.126. Oh, I can't right there. 126. There we go. Okay, so we've got $10,931.06. Nice amount of money there. $10,931.06. All right, now our friend Josh made an investment of $6,800 at simple interest of 12.6% for 4 years. Determine the end amount of Josh's investment. So initial amount P sub 0, 6,800. Interest rate still the same of 0.126. The time still the same, 4 years. We're looking for the amount in the account after this time. So since I'm looking for the A value, I'm going to use A equals P sub 0 times 1 plus RT. The simple interest formula, because it said simple interest in the problem. So we have A equals 6,800 That's 1 plus 0.126 times 4. And let's see how much Josh has in the bank. Okay, you probably have some maybe opinion on who's going to have more, Josh versus Sarah. Let's do the math, guys. And it looks like we got a little typo in the formula. How about that? Let's try this plus. Okay, so it looks like Josh has $10,227.20. So we got $10,227.20. Now the big question is, who made more, Josh versus Sarah? Well, I think we all know that Sarah made more, but by how much? So let's see, it was $10,931.06 versus Josh's $10,227.20. So let's do the math, you guys, and see who made more. So we have 10,931.06 minus 57.20. Wow, that's a lot. She made $703.86 more. All right, so $703.86 more. That's a lot of money. That's about 600 items in the Dollar Tree, you know. Okay, so there you go. So again, when do we use the simple interest formula and when do we use the compound interest formula? You want to use simple interest if the problem states simple interest, just like we did in part B. You want to use the compound interest formula when the problem gives some kind of a compounding period, general compounding, daily, monthly, quarterly, etc. Or if you're making a single deposit. Okay, so when you make a single deposit, you'll be using the compound interest formula. All right, so this wraps up part number 2, everybody. For your notes, and should your instructor choose part 3, you will see a part 3 appearing. Hope you enjoyed and learned a lot about compound interest, and you should have everything you need now to complete your Unit 3 homework number 1 assignment. Remember to get help. You can go to the ARC Math Tutors. They are great, or you can message your instructor.